Real pleasure to be here. I'm thrilled to be talking to so many people who basically are the guardians of knowledge, and so you all serve such an important purpose. And today I want to talk a little bit, not so much about my research itself. My research has focused on visual and image generating networks, diffusion networks to be specific. But I want to talk more today about LLMs, in particular. What I think may be somewhat different opinions about LLMs and what they can and cannot do than much of what you hear in the media and from many different sources. And then I want to talk a little bit about perhaps very, very real topics that are dealing with you guys today, that you guys are dealing with today, basically on the topic of AI crawlers and scrapers and what to do about them. To start, obviously, LLMs are very complex black box tools. They are honestly black boxes even to those of us who work in ML. We understand some of the mathematics behind it, but as far as how it actually works in practice, why it is that when you throw a certain amount of data onto these billion parameter networks, they start behaving a certain way, nobody understands. And that's part of the problem. Because when we don't understand, we start projecting things. We start, inferring intelligence. Oh, it's deceitful. It's lying to us. No, actually, it just found a weakness in the input because it's scanning literally every possible region of the feature space. But anyway, so we'll get to some of this. But these things are very large models, obviously, trained on trillions of tokens, billions of parameters in and of themselves. So there's no even with much smaller networks in the last generation neural networks, it was nearly impossible to have true interpretability, to try to understand why they were behaving the way they were. With this generation of generative AI networks, it is completely hopeless, and colleagues of mine who are more optimistic about DNN interpretability have largely thrown up their hands in this regime and just said, the heck with it, it's not going to happen. But today I'm going to try to talk a little bit about what are LLMs really doing, why they do the things that they do, good and bad, and hopefully give folks a better sense of why they do what they do and maybe push back on some of the marketing hype that's out there. So I want to focus on two questions today. Not super connected, but both I think relevant for the right audience here. So one, I want to talk about are LLMs the right interface for information and data access? And it sort of leads into the second question, but I want to discuss what they are and something that maybe perhaps you guys are hearing more about these days, which is large reasoning models, the LRMs, instead of LLMs, and just shed light on exactly what they are and what they do. Can we trust them? Can we rely on them as the interface to all the data that you all manage, right? Much of the knowledge that we have as humans. What dangers and harms do they pose to open repositories and librarians and libraries together today? And obviously, I know, sounds like you guys have already been discussing many of these questions. How do you deal with scrapers? How do you deal with crawlers? What can work when your hosting and network costs are going up by 10x and 99% of it is garbage that's not even going to a human being? So we'll cover that. I'm not going to talk about many of the other issues that are super important. Energy usage, climate impact, legality, ethics, impact on education, plagiarism, detecting AI content. There's so many things to cover, but and some of those things I work on, but obviously not time enough to cover all this. But happy to take that and talk about any of those things in questions if folks are interested. So the usual caveat first, I usually put up something like this when I start one of these talks, which is to say that generative AI is fundamentally very, very different from prior generations of AI. And in fact, generative AI has only really been public since 2022. Okay, so it is very, very different. I urge people to remember to distinguish the difference between these two types of AI. Not OI is the same, all AI is the same. The older generation of discriminatory AI, discriminatory not in a bad way, but literally in terms of I can tell A from B, that type of discriminating behavior, literally classification tools. Okay, those tools happen to be ethical. They happen to have no quandaries, no legality, no ethical issues about training data. They are also at the core of all the things that we think about, good things when we think about AI. Drug discovery, self-driving cars, identifying from an image, whether that's a person or a small animal or a stop sign. Medical imaging, climate modeling, recommendation systems, almost everything that you can think of that's reasonably good for AI systems is of that generation. Okay, so the new stuff, generative AI, is quite different. It generates things instead of understanding and trying to differentiate and identifying things. Okay, but I suspect most of you already know this difference, but I'm just trying to always get us all on the same page. I would say that 2024 has shown us that mostly, and I haven't done too much of this analysis in 2025 yet, but I think this is, from everything I've seen, still consistent, which is to say that most people don't love generative AI content that much. It is cheap, but it also looks cheap. It looks plastic, and oftentimes you can tell whether it's 6 fingers or too much gleam or too much of that sort of veneer of plastic lookingness, whatever that may be inside the image. People don't like it very much. So whether you look at news articles, whether you look at sort of advertising agencies are even warning their customers about, be careful when you use AI, because a lot of people don't like that look. A lot of people actually are offended by your use of AI. And we've now seen additional companies coming day by day who are apologizing for their use of AI, saying, oops, that was without our knowledge, that goes against our policy, some other artists misrepresented their content, were deceived, et cetera, et cetera. And the reputational backlash is always fairly significant. In a way, generative AI, the hype cycle, I think many of you, I'm sure, are quite familiar with the hype cycle with new technologies, really is in many ways past its peak, right? I just want to throw some headlines up here, but even sort of mainstream media that 2 years ago, I could show you very different article headings that were just like, oh my God, this is going to transform the global economy. This is going to be efficiency everywhere you look, et cetera, et cetera. Now we're all talking about what is the cost? What is the cost to human jobs? What is the cost to the internet in terms of AI slop? What is the cost to nuclear power that we're now entering an age where nuclear is the hot thing? Meta or Facebook just signed a 20-year contract from Constellation Energy to basically lease a almost dead nuclear plant for the next 20 years and keep it running. At the same time, we're recognizing from the research community and other places that AI is hitting a wall. We are already training, generative AI models are already trained on everything that we know. The only thing that's left is things that are being generated in real time by people on social media sites, on what used to be called Twitter, on Reddit, on Pinterest, those kind of things. And that's not that much content. Right? And so really, there is broader recognition that not only is generative AI not giving us quite what, was advertised, but also, we're really seeing a slowdown in what it can do. So let me come back a little bit and talk about what they are, particularly LLMs, and how to think about what they do and why they do bad things, or at least unexpected things, right? So first off, LLMs, large language models, are very different from diffusion models. I know they sound alike and they're all generative, but the architectures are all very, very different. So the things that I do with image models, I can't easily transplant into text models. In fact, actually, all the techniques are quite different, so they're really quite separate. All right? But every LM is a transformer. I promise this is the only ugly diagram schematic that I'm going to throw up here, because these are largely meaningless, except to show you that there's lots of pieces that people are putting together. And oftentimes when you see VCs and people talk about this stuff, they love this kind of stuff. They love the fact that you're putting more components together, and that is supposed to mean some sort of additional intelligence. But really, transformers and LLMs in general predict tokens. Given a sentence, cut off in the middle, what is the next word? What is the highest probability next word that would come out that fits all the training data that it's seen, that is most likely to sound like normal English language to someone who's consuming, a user who's interacting with this particular LLM. And that's how, that's why chatbots are so intuitive and they feel like they're real people talking to us, because they've been trained on literally, billions of books and articles about every possible colloquialism, every possible expression, every possible little story that you've heard or read, right? And so it's all about conditional probabilities. Basically, think of it as like, given this last paragraph, what is the most likely topic? Given the last sentence, given the last 2 words, given the last 2 chapters of a book, what is the most likely thing? And LLMs are basically like, if you can think of them as multi-tiered conditional probability sort of mathematics stacks, right? Normally you say a sentence and here, what is the next word? You have some very simple probability to calculate. But once you start stacking these up, there's a sentence level, there's a paragraph level, there's a chapter level, there's an entire, 200-page level of context. All those contribute to this aggregation of a probability guessing game on what the next token should be. Okay, and this is how it's able to actually generate longer form text, things that actually look like a short essay or maybe even in some cases short books. Okay, but at its core, this is all about asymmetric token prediction. There's no memory, there's no understanding, there is no knowledge. There just does not exist. Okay? So let me give you all a little bit of a mental model that helps me understand and think of LLMs and when they make mistakes and why they do. And it explains a lot about training, what training does, memorization, hallucinations, all that. So I tend to think of LLMs and text generation as sort of like a really dense, deep forest, okay? And when you first initialize an LLM with no training, it is just that. It's like the wilderness, okay? You have nowhere to go, and every direction that you go generates a new token or a new word, but you have no idea what makes sense. If you start walking around randomly, you just start generating gibberish. So what happens when you add training data? Well, every single subsequence of tokens, every sentence, every chapter, every essay, every line of code that you feed in as training data basically walks a certain path through the training, through the forest, okay? And it starts telling the LLM, yeah, this is okay, this path is okay, all right? And the more that you do this, because again, remember, we're talking about trillions of tokens, billions of books and articles and everything, basically these crawlers can get their hands on as being fed in. And so over time, some of these tiny little footpaths through the forest become well-trodden paths because the grass has been worn out, and now they almost look like cobblestone little paths and hiking paths. And then over time, they become dirt roads and they become really obvious because so many training samples have gone past this particular sequence that this sequence is absolutely the right thing to do and it's high probability, and if you choose it, nothing will go wrong. Okay. So this is what training does for an LM. And once you're done with training, then you have something that looks like this. Okay? And all these paths denote sort of sequences of tokens that if you walk down a particular path, you get a particular sequence out. Right? So I guarantee you something like this, if you look for a particular common dad joke, for example, it would be in here as a little path, probably fairly worn out, just because so many dad jokes on the internet. Right? But also similarly with things like Harry Potter stories and chapters of Harry Potter and Alice in Wonderland. As I understand, I think Alice in Wonderland and Harry Potter are the 2 most copied, or the 2 sort of book sequences with the most number of duplicates on the internet. So they're the most memorized by LLMs. All right? So really intuitively what this means is that hallucinations are basically fundamental. What are hallucinations except they're just when you are walking down one path and you accidentally take one of the side paths that you shouldn't be, because they will intersect at all the tokens that intersect. Okay, so LLMs, because they can't regurgitate the same thing every single time, there's a knob called the temperature. Temperature basically tells an LLM how free it should be, how diverse, how random it should be in producing tokens. And when you increase temperature because you want to not repeat the same thing over and over, you want to have variety in your output, you increase the risk of basically taking the wrong path down, and all of a sudden, you're talking about some song or you're talking about some story in Philadelphia, all of a sudden you veer into a Will Smith lyric about Bel Air, right? And so, yeah, so that's what hallucinations are, basically. So really, hallucinations are fundamental. They are part of the architecture. They are to be expected. They're not unexpected events. Memorization is fundamental. The more copies you have of some content, that path gets much more worn out, particularly if it's unique If it's a unique sequence, for example, a song lyric, what that means is that there are no sub-branches off that path. Once you get on that path, you start with, the first line of Bel Air, like, there's nothing really that matches it that veers off in a different direction. You just start walking down that path and you regurgitate the entire song. This is why LLMs do regurgitation and so on and so forth. So what you see today with LLMs today largely is kind of okay because there's a ton of pre and post inference queries and filters that are applied by these companies. Every time you ask about a known copyright book, it'll filter it, it'll identify, it'll just say, no, sorry, we can't do that. So that query never even hits the model. After it hits the model, when queries do get through the model and the outputs come back, the outputs are again checked against content to make sure that they're okay for you to consume, that it doesn't violate copyright, that it doesn't say bad things, that it doesn't, all the things that you expect. And so what we actually experience is highly filtered, and that's why it looks like it's behaving okay, but really the models themselves are, not nearly as great as they look. All right, so reasoning is a term that is used to describe multi-step inference. In other words, if LLM does give you one thing at a time, reasoning does more than that. And I'll talk about that in a little bit. So very quickly, I think you all probably have already experienced this firsthand, so I don't really need to say this too much. But things like the fact that it's asymmetric means that you can't go from A to B and then B to A. There is no such thing. They're not equal. There's no equality in LLMs. So the old joke on the internet, on Twitter, used to be that if you ask an LLM who Tom Cruise's mother is, it will know the answer right away. If you flip it around and say, who is, I believe her name is Michelle, if I remember, because I've given this example so many times. But if you say, who is Michelle, her full name, it'll get confused and have like no idea. Or it'll give a completely wrong answer. Okay? And the reason behind that is because there are so many more articles that talk about Tom Cruise and then lead to his mother than vice versa. That asymmetry just shows up in the training. Okay? The other challenge with LLMs is that it depends on the training data. And the problem is that when you are training on everything on the internet, you can't, by definition, curate it. You don't know what's garbage. You don't know what's a joke. You don't know what's a complete prank. And you take it in and you think it's legit, and that changes how the LLMs think about the world. I'll give you an example in a second. Right? And the other thing that's quite relevant, I think, to this audience is that LLMs are basically trained on everything under the sun already. So even though companies are desperate for new data, in reality, it's going to be 0.00000, however many zeros, 1% of the training data they already have. And so in reality, it's not going to make that much of a difference whether they license more data, whether they crawl more data. They just want more because it's their one hope, but it's not in real terms going to change tip the scales and remove hallucinations, for example. So I don't know if you guys see this up here, right? But this is a standard example, right? If your cheese is falling off your pizza, add some glue, Elmer's preferably, because that definitely fixes everything, right? I mean, you all have seen this. The reason I include this is because of this thing. Right? So this actual example, this little glob of knowledge can be traced back to a 11-year-old post on Reddit. Okay? I blocked the user's name because it's a profanity. But that user on Reddit was very serious about why glue helps. And in particular, 8 ounces, which, I think, 1/8 of a cup, right, which you see matches up with the answer given by Google Gemini. All right? Obviously, there's a lot of things, and sometimes it actually gives an attribution, right? So when it says jump off a bridge, at least it tells you that it came from a Reddit user. So there is improvement. It's just not perhaps what we really want. People, and I teach a class on adversarial machine learning, which is security in machine learning systems, and sometimes students see this and are like, Ben, man, come on, this is like ancient stuff. This can't be like, I'm sure they've gotten better. So I made sure that I got something a little bit more recent. And this is funny, right? So I won't give you the version that my wife got when she tried it, which is even funnier. But so this is, me. So I say, my standard test is new LLM comes out. I say, it's a little egotistic, but I know myself pretty well, so I can detect errors. I say, who's Ben Zhao? Do not search the web. The reason I say do not search the web is because modern LLMs so often are augmented with web search. And so if you actually want to see what the LLMs know, you have to say, do not search the web. Otherwise, it'll like fix all the hallucinations, but then it's just a wrapper around Google search engine, which, we had that already. So it says, blah, 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 Ben has a thing, he writes some of these papers, and it's like, okay, that's fine. And I say, give me a couple of recent papers by Ben, do not search the web. This is a test that no LLM has ever passed, ever, right? And it makes perfect sense because what it's doing is token predicting. So it's like, okay, given Ben Zhao's name, what is the most likely token that starts one of his papers? And yeah, these are reasonable guesses, but God knows I would never write these papers. They make no sense whatsoever, but they'll explain, right? And so, yeah, this is completely wrong. I will say, tell me about the first paper, because I'm playing along. And the LLMs are like, oh yeah, let me explain. The core idea is to let users share media like live streams without revealing their exact identity, which doesn't even make sense. Like, I'm going to share a live stream with me, but hide my identity. Anyway, this is just complete BS. And it says, would you like a conceptual diagram to illustrate how such a system might work? I was tempted. I really was tempted. I was like, you're going to draw me something in real time? But no, I said, this paper does not exist. And then the media says, you're absolutely right. That was a plausible synthesis based on Ben's known research themes, but it does not correspond to a real published paper by him. The bold on the does not is actually provided by the model, not me. Thank you for calling that out. And I'm like, great, okay, well, that's helpful. Anyway, so, but then you hear a lot about these things like LLMs are intelligent, they pass tests. Well, are they really? So I'm just going to point to this image. How many people know what this is referring to, right? So the younger people don't get it. I show them this example. They're like, oh, dude, what volleyball? Why? What is that thing? And I had to explain Castaway is a movie. Tom Hanks is a pretty famous actor. Anyway, this movie is all about Tom Hanks being so lonely that he has to imbue basic intelligence and sentience on the volleyball just so that he doesn't go nuts. Okay? So psychological anthropomorphism is a known thing. It is a behavior that we all do, and this is why we name our cars. I don't, but a lot of my friends do. It's why you name stuffed animals. This is why you name like desks and pens and lots of things. But this is much worse now because LLMs are actually trained, designed to mimic human speech, right? I remember back in like the early mid-90s when like Eliza, that goofy little online psychologist would give you the same answers back and forth. And people still back then thought, oh my God, Eliza gets me, right? And so you can imagine how like chatbots now with their capabilities are much more able to do this. And for those of you who read the recent New York Times article by Kashmir Hill, you know what I'm talking about. It's a little dark place to be. If you don't know what I'm talking about, Google it. It just came out a couple days ago. Cash is a great friend, and she writes these very thoughtful stories, and this one is a little bit dark. Anyway, but then people say, like, but it passed all these exams. Like, how could it not be intelligent? It's doing all these great things. And then, my question always comes back is, yeah, but like, how many answers to these questions are already in the training data? And in fact, I've asked this of a number of, AI researchers from all these big tech companies when they visit us, when they give a talk, we're chatting in my office, et cetera. I ask this question, and generally speaking, nobody has an answer. They sort of look at me like, why would you ask that question, Ben? Like, nobody thinks about that. And in the sort of commercial AI tech space, I would say this is well known, but is rarely acknowledged. There's a recent paper out of Apple Research that talks about this and talks about this is impacting all the things that we do as far as AI benchmarks, but it's one of the few papers that actually discusses this in public. All right, so let me talk about reasoning models, which is quite interesting because this is the latest thing that, has been for the last few months, and reasoning is, this is like true thinking, right? In fact, it's in the name of the model, Claude 3.7-thinking. So it must be thinking. And the nice thing about this is that when NVIDIA CEO Jensen Huang, he's a very smart guy, and when he's talking about a keynote at GTC, he's very excited because he's like, well, look, these things are going to take 100x more compute than LLM queries, right? So you all need the next generation GPUs, and that's great for NVIDIA. But really, reasoning represents two things. It represents chain of thought processing, which I'll talk about in a second, proposed by Google DeepMind in 2022. And it relies on this thing called self-verification, proposed by some Chinese researchers at a paper at EMNLP 2023. Let me talk about what they are so you all can understand what reasoning really means. Chain of thought reasoning basically does this. It takes a complex problem and it asks the LLM to basically break it down, decompose it into sub-problems, okay? And then solve each one in turn. That is reason, okay? So the idea is that if you break problems down into smaller subproblems, then you're going to be less likely to make errors on smaller tasks that are simpler, okay? And then when you put them together, then hopefully you get a better answer. And that's reasonable, right? So if you look at, sorry, maybe that's not quite readable, but you know, if you ask for sort of intermediate steps, it has a greater chance of getting things right. Verification is even simpler. Verification is the idea to ask LLM to verify its own result. Self-verification. So you take the same query, you write it in different ways, and you send them all to the LLM, hoping that LLM will give you different answers. And then you take all the output, and then you give it back to the LLM and say, given these answers, tell me which one is more likely to be the right one. Okay? And so the idea is that if you make randomized errors, then hopefully you'll make randomized errors less, and then you'll sort of take the most common answer. It's almost like majority voting when you're taking, you know, exam answers that you're not sure of. Okay, poll your classmates. Maybe, you know, wisdom of the crowd or you know, that will solve the problem. So take a query, generate, you know, number of different variants of the query. You send it all to the LLM. You get a bunch of different answers, and then you send it all back to the LLM again and say, choose one of these as the most likely version. And then it will say, yeah, I think A3 is probably the best one. So then we think, well, you know, does this really solve the problem? Because boy, does it sound like this is the answer, right? They think they are doing all this. I've been watching some YouTube videos from some of these companies and VCs, and I'm still trying to recover. But a lot of this is really like, you know, they don't talk about technical things. They're like, look, it's thinking. It's thinking really, really hard. Okay, this is why it takes longer. This is why, you know, the prompt says, I'm thinking, give me a second, all these things. So I did this thing accidentally on Monday night. I was doing a different talk, and a friend of mine asked me this technical question. They said, hey, I'm trying to, you know, retrieve some data, and somebody says, I can just give the 65 terabytes of data, which is a lot of data, on Amazon, and just give it to me. Would that be easier than shipping on hard drives? And I said, no, that's not great, because like, you know, storage is cheap, but like when you download things from Amazon, it's going to cost you a lot of money. But also, like, I'm thinking like that'll take a long time, right? Because I used to do networking for over a decade. And so like, how long did it take? So I'm trying to give her an answer. So I go on Google and I made the mistake of asking Google, like, you know, how long did it take? I actually was trying to just do a normal search thing, but Google Gemini jumps in and says, oh, I'm intelligent. I'm going to tell you the answer. So this is the first answer I got. Okay, how long would it take to transfer 65 terabytes out of Amazon S3? Okay, and it says here's a breakdown by different scenarios. The first one, which I think is fine, 1 gigabit internet connection, takes you, assuming 80% utilization, which is pretty reasonable. You can't get too high of utilization. It will take 23 days. I'm like, 23 days is a long time. I don't think it takes that long. I mean, like, I'm just in my head, I'm like, ballpark, it should be a little bit less than that. That seems nuts. Okay. I asked it again. Literally, I forget the prompt. I didn't include the prompt, my mistake. The prompt is very similar. I basically said, I simplified it. I removed Amazon. I said, how long does it take to transfer 65 terabytes off of a over 1 gigabit link? And it takes 15 hours. I was like, that is, one, is completely different, and two, that seems too short. It should take longer than that. But at least it gave me a chain of thought. It gave me a bunch of, you know, sort of steps in between, did the math for me. I'm like, okay, I don't know. I still don't trust it. Maybe I should try again. So I do it again, and I get a third different answer. And this is when I'm just like, why? Okay, so then it gives me this long counter answer, and it says it's slightly over 8 days. This is actually closer to my own sort of mental guesstimate. And I'm like, ugh. So I give up, I get a calculator, I start writing everything down on paper, and I crunch the numbers, and it turns out this is the right answer. Okay? And I go back, I'm like, how did the other ones get so far off? And so I looked at the first one, I can't debug it because all it does is says 23 days. I have no idea where I screwed up. No idea. It's just wrong. But I know it's wrong, okay? So not much I can do about it. I go to the second one. 15 hours. At least this one shows me math. So I'm like, there must be some error in here because I can't possibly, obviously I trust my own numbers a little bit more. So I run through like the whole process and I find not one, but 2 errors. Turns out one of the errors doesn't impact the result because it's, so let me show you. So the most important error is that 545,000 divided by 3,600 seconds in an hour is not 15 hours. It's 151 hours, only off by a decimal point. So in fairness, my 10-year-old sometimes does the same thing. There's a separate error, which is 65 times 1024 times 1024 is not 68,157,440. Everything is similar except the last 3 digits are wrong, but those 3 digits don't matter too much in this instance. So it actually doesn't impact the result. The first error is what causes the problem. And if you compute the fact that 151 hours, in this version of the question, I didn't ask for 80% utilization, you divide it by 0.8, you get roughly about 8 days. It's still a little bit off. I'm not sure where the remainder error is coming from. I stopped caring at this point. So the error, the moral of the story is that you can't build a reliable tool using broken parts. And large reasoning models are basically using LLMs to build bigger LLMs. And this is, I hate to say it, this is part of the problem with a lot of the work in the LLM space today. When you start with something that breaks, and it breaks indeterminately and unpredictably for some amount of time that you cannot detect reliably, it is very difficult to build a reliable tool out of that. Okay? Reasoning, COT, self-verification, all these use LLMs as a building block to build bigger models. And, it's like using an occasionally broken calculator to check its own work. You just don't know when it's going to break in verification or in generation. I will say that moving forward, one of the things that is much more reliable is RAG, which is retrieval-augmented generation, basically augmenting LLM output with databases or, real-time web search. The problem is we already had this, right? And so my personal expectation is that at some point, maybe a few years in the future, LLMs are basically becoming human speech wrappers around a database or around a search engine that we already have. And if that's the case, I'm sort of okay with that. All right? I get this sometimes, as you might imagine, right? I speak to a lot of, whether it's my colleagues or students, or people are just like, dude, you're just a hater, man. Like, you're such a pessimist. Everything is dark to you. The world sucks. I'm like, no, I actually was a pretty happy guy before all this stuff came along. And so I will say, there are many people who actually agree with me. They just don't speak out publicly because reasons. Some of those reasons being that their students are dependent on funding from many of these companies. Many of their own grants depend on some of these own companies. Thanks to Chicago and the tenure system, I don't care anymore, which is why I'm able to say stuff like this. Okay? Thank you. That's an odd comment to be applauding on, but I'll take it. But if you look at a survey of, this was done, I forgot, but by who, whether it's Futurism, I guess. They did a anonymous survey of AI researchers. And these are over 1,000 researchers in the AAAI space, which is sort of, American Association of Artificial Intelligence or something similar. AAAI is one of the big conferences in AI. And basically most people agree that this is, that industry is pouring billions into a dead end. But nobody says so in public, except maybe one person. And this is Yann LeCun. Yann LeCun is a Turing Award winner. Justifiably so. He was one of the few people in the, decades ago who pushed for deep learning and said AI is going to be a thing. All you need is more data. And so, the Turing Award winner, the Turing Award, for those who are not familiar, is basically the Nobel Prize for computer scientists, because, Nobel didn't like math or computers didn't exist. But so he's one of the the grand or the fathers of AI, for example, right? And he is much more optimistic about next generation AI architectures, but very sort of pessimistic about the current ones. And you can go online, and Yann has been particularly vocal in the last couple months, I think in part because their models for next generation stuff is becoming more mature and he can talk about it. But he, will post stuff like this on LinkedIn where this is one of those papers that looked at the fact that LLMs fail badly on the latest 2025 US Math Olympiad, unlike all the prior Math Olympiads. And it's like, well, shocker, why? Maybe it's because all the other Math Olympiads have been duplicated and the answer sheets are in every study guide online, and the 2025 one is not. And so there's a paper studying this and saying, well, maybe we're over-leaning on LLM memorization rather than something more important and meaningful as intelligence. All right, that's all. I'll stop there. But I just want to give folks a sort of more, frank discussion about what LLMs are, what LRMs are, what they're actually doing, and some of the fundamental limitations. And then everybody can make their own judgments about, what that means for information exchange and what that means as people start to rely on these tools more and more as their go-to tool for pulling knowledge out of the internet, right? Which is really, if you think about it, a concerning process. But let's talk about something else that I think you guys are much more, concerned with, like immediately, right? Crawlers. So I will just say that as background, I did my PhD in large-scale decentralized networks back in, got my PhD in 2004. And in the early 2000s, I was one of the few people who sort of co-invented this new era called structured peer-to-peer networks, whatever. Old stuff. But for more than a decade, I worked on networking, and a lot of that was measuring the internet, modeling the internet. And so I wrote crawlers and tried to think about how to stop crawlers for quite a few years. So I will say that today, internet traffic has changed wholesale in the last couple of years. And most people don't understand this yet. But if you look, you'll see enough articles, they're just not as covered as much, right? 80% of web traffic today is bots, which is absolutely insane, absolutely bonkers. Like, 3 years ago, 4 years ago, that number used to be like 5%, and it was all Google, and maybe a couple of smaller companies, and that's it. But now this is dominating traffic. I remember there was I think a time in 2023 when the bit flipped and there was more artificial traffic now feeding AI online than there were people searching and getting content online. And I thought that was crazy, but 80% is now bots. These crawlers are now draining small websites. They're ratcheting up internet costs because when the crawlers come for your content, you're the one as the hosting service paying for the bandwidth. Right? And so, whether it's Wikimedia dealing with a flood of AI bots, whether it's other smaller companies, you see this everywhere, right? There's a guy on LinkedIn who I saw a couple months ago who was like, oh my God, last month AI crawlers took, 90% of my size traffic and made me pay penalty fines in my hosting service and so on and so forth. So how do web crawlers and scrapers work? This is something that I want to make sure that I get across here so that folks understand how and why they're so difficult to stop. So in normal web server access, right? So let's say, someone up there is still using Firefox. This is an old GIF. They send an image, they send a request across the internet. The server says, oh, sure, you want this particular HTML file, here it is, and you get one file back, okay? User clicks link, browser sends out a request, you get a response, it's all fast and lightweight and all good, okay? Generally speaking, low cost for everybody, okay? How do scrapers work? Okay, web crawlers, scrapers, the first one looks just like humans. The first, index.html, the crawler says, hey, give me the index.html page. And then what it does is it parses every single link on that main page, and it spawns off a bunch of other crawlers. And then they go in parallel and send all the parallel requests, fetching every single other page in parallel. Okay? And then they just repeat. Every single page that comes back is parsed to harvest all the potential links. That's put on a job queue, and then all the spiders just continue. Okay? But it's important to note that the spiders aren't doing much work other than sending a request to your server. Okay, so for them, it's very lightweight. This is why the crawlers are efficient. You can run thousands of crawler instances on a single laptop and not have it burn hot. It's just very, very lightweight work. All the heavy work is done on the server, and this is why ISPs, this is why hosting services, this is why small companies are getting hit and falling apart. Okay, and then you just repeat until every single page that can be reachable has been downloaded. Okay, so how do you slow them down? I'm probably running out of time, so I'm going to go through this fairly quickly. The short answer, it's really, really hard. Okay? Back in the day when this used to be like one crawler or the person doing the crawler had limited resources, you had tools. Today, it's very, very hard because these crawlers are now run by Google, they're now run by Microsoft, they're run by at least smaller startups with a lot of money behind them who are willing to pay. Okay? So things that you can try, you can rate limit per IP address. Well, turns out most of these companies have thousands, if not tens of thousands of IP addresses, they just rotate. You can rate limit per account. Well, most content happens to be public, but even the ones that require credentials, you can just share the cookie credentials across multiple threads on a single machine, and you can't really, slow them down. You can slow down responses to each request. You can do that. It actually obviously slows down responses to users quite a bit, so legitimate human users are getting hit. But crawlers actually don't care because they're not actively waiting on you. They just send out more requests in the meantime. It's like I can put, one job in the queue, and then if you're taking longer, that's fine. I will generate 5,000 other jobs at the same time while I wait for your answer. When you come back to me, actually doesn't matter. You can block them using captchas. This is actually something that might slow them down meaningfully because captchas are not foolproof. Today, you can use AI tools to solve them. You can forward them over the network to a developing country where you pay someone else a dime or 5 cents to solve a dumb captcha, and then they send back the answer. This is common. But at the very least, it will sort of increase the cost a little bit for crawlers. Okay? You can return bogus data in circular links. I've seen startups propose this. This does not work. What it actually does is that it greatly increases the cost on your own server because you're trying to be cute. You're trying to give it like circular links and stuff like that. Crawlers are just like, whatever, dude, I'm just going to request the next thing. I don't care if it's going in circles. It's just costing you more. Robots.txt and do not crawl directives do not work because they're oftentimes just disregarded by crawlers. We have an upcoming paper at IMC Internet Measurement Conference that actually studies this with some colleagues at UC San Diego. And, some of the bigger companies have to behave because they know there's a lot more tension on them. There's Senate hearings. There's the reputational risk. But for all the smaller companies, they don't care. Other approaches. This is a legitimate answer. I've heard a number of, friends mention this. Why don't we just offer the data to the AI companies, right? Despite what you might think about whether they're going to hallucinate or do bad things with the data, if you give them the data, maybe it'll help. Actually, probably not. Because most of the crawlers are out there are pretty dumb. And they're not going to run down a list of IP addresses and say, oh, this is the UChicago library. They've been nice to us. We have all their data. Let's not bother crawling them. No, actually crawling to them is really, really lightweight, so they don't care. They will come and hit your website anyway, even if they have a full copy of your data sitting nicely on a hard drive or a USB key. In fact, it costs them more to maintain and skip list than for them to just crawl everything. So unfortunately, I don't think that's going to stop them. And to be honest, most of the traffic has come from smaller companies anyway, who perhaps you've never heard of from countries that you're less familiar with. And so they certainly are not going to care. There's one thing that you can do by breaking coordination between crawlers so that they can't share links that can slow them down. We wrote a paper. This is why this stuff is so old. We wrote a paper on this at a conference in 2010. But even then, it only slows them down a little bit. It decreases the parallelism that these parallel crawlers can use, but it doesn't fundamentally solve the problem. The most serious tools today that basically you can actually use is things like Cloudflare and Datadome and some of these network level blockage and filter mechanisms. They're not great. They're expensive. And, for smaller sites, and there are logistical reasons why they're difficult to deploy. If you're in a subdomain that belongs to a bigger domain, it's oftentimes difficult to get Cloudflare only for your subdomain and certain services. So unfortunately, there's not a whole lot of really great solutions out there. I was just talking with some of the other organizers because there are people in the networking community who are literally considering a reshaping of the internet network architecture just to deal with this. Because the internet, as we know it, has fundamentally changed. The usage pattern has been changed to be dominated by AI bots. And many people in the network community are thinking, how do we completely change the internet just to deal with this and to limit that traffic? Okay, I'm sorry, I'm a little bit over time. I will stop there and ask for any questions. Please. Yeah.
questions?
Any questions? Folks. I think they want it for the recording, so yeah.
You pointed out that there's a lot of skepticism privately, even among those in the AI industry, that this is going to hit a dead end. Do you feel that that's going to happen, and does that offer hope for us that are being crawled and scraped?
I think it's already hit a dead end. I think if you look at what the sort of quote-unquote innovation now is, it's not getting better or more accurate models. It is about pushing models sort of breadth-wise into more different applications, right? So that's where much of the work is now focusing. You don't get the models that come out every 3 months now, because even when you add all the data in, the scaling laws, in these models basically say that it's not going to make much of a difference unless you can like double the training data set, which is basically impossible given everything that's ever been written down is already in the training set. So yeah, I think it's already hit a wall. I think people are being very creative and trying to overcome some of these things. LRMs are basically like having a model check itself so that, in hopes of reducing randomized errors. And there is some effect, but ultimately there's only so much you can get out of that. But the second part of your question, will that help us? I'm not sure. I think there are enough companies who still believe in the hype, who want their own LLMs, that they will still justify all this web crawling and all this traffic and all the costs that you guys are all paying. And so that, unfortunately, will take longer to dissipate.
Hi. Hi. I was wondering, sort of maybe following on from what you were just saying there about pushing AI broader. We've seen a number of talks over the conference of people putting AI searches into their repositories. And I've been kind of thinking, oh, we're going to have to do this because people are going to expect it. I mean, is that the right attitude to take? Should we be doing it anyway because everybody's doing it? Or should we be taking a more pessimistic approach and saying, no, it'll all go away or it'll change for the better in the future?
I think there's something, sort of a third option, right? What you're talking about, this idea that everybody else is doing it, you might as well. It's almost like a mantra in the AI world, right? It's inevitable. Just take it. And maybe I'm a minority, but I don't think anything is inevitable. Particularly, it's stuff that we're building and using. And so, if Terminator comes out of nowhere, maybe I'm inevitably dead. But until that moment happens, I can choose not to build Terminator. That's just goofy, right? Those are sci-fi movies for a reason. So I don't believe in inevitability. And I've been teaching my students not to believe in inevitability, that they don't have agency or power over how technology is designed or deployed. And so, yeah, no, I think we have power. I think people can basically say, yeah, no, this is not how we're going to teach our class. This is not going to how we're going to accept that LLMs are everywhere, therefore, by all means, write your essays using LLMs, and I'll take it. No, I just refuse. So that's another option. And maybe it makes you less cool and less chic, and there'll be less people coming because they think the other thing is slicker and cooler. Well, okay, less traffic. That's probably a good thing. In some ways, I'm joking. I'm being facetious. But I do think that, saying no is a perfectly valid option. And I do think that, at least my personal opinion, that given a couple more years, I think the tide will turn and people will understand all the limitations, and the majority of people will think perhaps like me, but who knows? I could be deluding myself.
One thing I've always wondered is the interaction between human languages and the LLMs. So if I run a query in English, am I getting results from English training data or Chinese training data? Or if I run a query in Croatian, is my training set much, much smaller?
Yes. Your training set is much, much smaller. In general, training data does not sort of map particularly well. There is some mapping. Once you train a particular feature space based on initial tokens, assuming that the same concepts map out to a different language, then the structure of the feature space will be something similar. And if you have a translation mechanism that's built in by a sort of language comparator, then some of that feature space can be usable. And that's how some of these other LMs in other languages are being bootstrapped. because they're not getting trillions of tokens in their own language. Oftentimes, they're bootstrapping off the main feature space. But yeah, but for sure, if you go to a language that has less training data, then it will not be as smooth. There will be sort of more sparsely trained areas where it will, screw up more. Yeah.
One back there, and then one up here. Yeah. So I was wondering if you can say a little bit about what you see as the proper role for AI and LLMs particularly in the coding space, in the space of, this is a community that is constantly starved of resources to develop code, and we have a ton of legacy code. What do you see as the potential there?
Right. So I just want to point out that, before generative AI came along, there was things like GitHub, there was Stack Overflow. You could literally go on and you can do a search in Stack Overflow and most likely get snippets of code that do exactly what you're trying to do, right? So that process is more or less being automated in a way by things like, Copilot, except when you do it from the line level up, it's actually a lot more prone to mistakes, right? I would actually think that a sort of human language wrapper around a code library would be far more effective at finding things that actually solve your problem without bugs, because then you're at least using snippets of code that is well tested and known to be bug free. Perhaps not exactly in the purpose that you designed for, but at least you would see that discrepancy. So, I think you should try it. I know that I've seen, students try to use these kind of tools. I taught a class on system programming in the fall where, being the masochist I introduced an assignment that basically asked them to implement a LZW compressor, which is literally equivalent to the sort of compress command in your Linux box. And it's fairly complex protocol. You had to compress everything perfectly and regenerate the original using your decompress tool. And at the end of the quarter, I had a no AI policy. At the end of the quarter, I had a student come up to me in my office hours, basically say, Professor, I'm so sorry. I did violate your policy. I tried to use LLM to generate this code. And that's the reason why I failed the assignment 2. Because it took me 2 weeks to try to fix their code until I finally gave up. But by then, when I started trying to write my own, it was too late, and I just didn't have enough time. So I do think that they're fundamentally limited. You can imagine, at least based on my beliefs of how they work and their limitations, code is not something that is nearly amenable to sort of phrasing and token prediction as some of the other things. So once you go beyond well-written code that everyone has written, so many duplicate copies where it can regurgitate how to implement a linked list perfectly, once you go beyond those kind of standard examples, the bugs are frequent. And worse than that, they are very, very difficult to detect. Sometimes you get a ginormous thing of code and you have no idea where the bug is because you can't even understand the code in the first place. So that's one of the challenges. So I would say try it. See if it's able to retrieve things that you're looking for. Maybe people have already implemented it. If so, then great. Otherwise, it might be a challenge.
We're going to do one last question up front and then move on with the program. So,
yes. Oh, go ahead. Sorry.
I've been wondering if there's some way to get the word out that if you're going to write a parasite, write a successful parasite that doesn't make its host determined to kill it.
Yeah. I mean, I don't know. I think we got enough of those messages in all the movies that we've seen, and yet somehow people are not interpreting those as warnings or interpreting those as guidebooks. And that's perhaps a failing of maybe the VC infrastructure or the world we live in. But yeah, I think the value system is a little bit off. It's much more about how much VC funding can you get in the next couple of years, and not so much about what is this product actually going to be able to do technically, actually beneath the covers. So yeah, I hear you. But unfortunately, or fortunately, I'm not in that world.
Funding's a nice segue to my question. Like other libraries, we are sometimes approached by tech companies. Although we recently had one in who said, you have all these books, they are fact-checked. And I'm like, well, we have all these books and they're not all fact-checked. And turns out they thought we were the University of Chicago Press. But that's another story. But they do come to us and some of them play nice and say, well, if you give us some data, we'll pay you. Do you think we should just take the money?
I remember when Reddit first did this, and Reddit signed a licensing deal with, I think, OpenAI or Microsoft for like, I don't know, 50 million a year or something like that. And everybody thought it was ridiculous. Not the fact that they did it, but the fact that it was so low. Because these companies are desperate for content. So I would say, you know, if you're gonna take the money, then make sure you get a good chunk of it. You know, make sure you get your money's worth, because this is literally the one thing that they need, even though it won't necessarily solve their problems, but they really want it. So might as well get something, you know, get as much as we can out of it. You know, personally, I would say no, but again, I think in realistic terms, and given the financial, you know, situations that all universities and certainly libraries are in, I can absolutely see an argument for you know, accepting that type of proposition. I would just say milk them for all they're worth, because they have billions. And there's absolutely no reason why, you know, they shouldn't donate a lot of that for a great purpose like a library. So.
Can we thank Ben for his...
Thank you.